Answering this question about the hydrogen ionization energy doesn't actually require any calculations. The answer is actually right in front of you on your formula sheet for this course. The important thing is just understanding what's going on. Now, you'll notice on your formula sheet, you have an expression for the energy of the nth energy level of a hydrogen-like atom. That is, En is equal to negative 13.6 electron volts multiplied by Z squared on N squared. And in this formula, Z is the nuclear charge, and N is which energy level we're talking about. Now, notice that there's a negative sign in front of here. So if we were to set N equal to 1, we would have the lowest energy level, and you can think of that as being in the bottom of a potential well. So we've got N equals 1 somewhere down in the bottom of the potential well, and this is like being in the the analogous in classical mechanics would be being in the gravity well of a planet. You need energy to actually rise up out of that, and like gravity, the energy is negative. So down at N equals 1, the lowest energy level, we have a negative energy, and as the energy gets higher and higher, the energy levels get higher, the energy will increase, but they will still be negative. That is true up to a certain point, however. So we have these energy levels going up. Now, as N gets larger and larger and goes to infinity, this whole thing will get smaller and smaller because the energy will get smaller because we're dividing by, it will get smaller in magnitude, I should say. It's getting larger, but just by being less negative. So, with that in mind, as N goes to infinity, we get to the highest energy level we can get, we'll end up with an energy value of 0. And what that actually means is we've escaped the potential well, and the electron that we've sort of ionized away is now sitting somewhere up here at the baseline of 0 energy, outside of the influence of that atom. So for that reason, it's probably very easy for you to see what the ionization energy would be. If we start off at negative 13.6 electron volts, to get the electron up to an energy of 0, which means it's beyond the reach of the atom, so to speak, it's no longer bound, we need to put in 13.6 electron volts of energy. So the ionization energy is 13.6 electron volts. So, and you can see that was sitting in the equation the whole time, but it's interesting to note, and I'll note for a second, just a reminder, for hydrogen the nuclear charge is of course 1, and we're comparing the lowest, so we really end up with negative 13.6 electron volts 1 over, and then of course we want to find what's the minimum energy in the bottom of the well, how much do we have to overcome, so we'd be putting 1 squared on the bottom, the lowest energy level, and we end up with that as our ionization energy.